Okay, so we already looked at the fundamental theorem of algebra, which states that a polynomial of degree n has n linear factors in the complex set. And therefore it has n number of roots in the complex set. So if you're unsure what I'm talking about, I'm saying, well, if it's got z to the power of 2, then if we were to make this expression equal to 0, there is 2 solutions for that root. Okay? Or we could put it another way. We could say we could factorize this such that it's in terms of 2 linear expressions. Okay, so let's start by factorizing this, and then we'll make more sense of it afterwards. Okay, so if we've got 5z squared plus 20, I'm going to start by factorizing that and saying, well, 5z squared plus 20, both terms are divisible by 5. So I could say 5 is equal to 5 times by z squared plus 4. Okay? Now, inside this brackets, I'm going to look at saying, all right, I've got 5z squared, and instead of having plus 4, I might say take away 2i in brackets squared. Because that's the same as positive 4. Okay? If I square I end up with negative 1. Okay? And negative 1 times negative 1 gives me a positive here. And then 2 squared is giving me 4. So all I've done is, if I've got this plus here, and I want to get it into the situation where I've got the difference of 2 squares, I can use this idea of I squared gives me negative 1. Okay? Let's continue. 5, so I've got difference of 2 squared, so that's going to be 2 squares, sorry, would be z take away 2i multiplied by z plus 2i. Okay? And then I factorize this. Okay? And notice, because it's got z to the power of 2, I've been able to factorize it in terms of 2 linear expressions, right here and here. And then if I made this equation equal to 0, I could work out the roots by solving for z and using the null factor law. Okay? Let's look at another example. So I've got factorise 16z to the power of 4, take away 625. Now, first of all, I always look for, is there a common factor between these two terms, and bring that out. And there isn't going to be. So the next step is, if I've got take here, I should be thinking, there's probably a difference of 2 squares happening here. So I could rewrite this as 4z squared, in brackets, to the power of 2, take away 25 squared. Okay, now I have the difference of 2 squares, here and here. So I'll factorize using that idea. I have 4z squared, take away 25, 4z squared plus 25. Now again, I can rewrite this in terms of the difference of 2 squares again. That's the same as 2z in brackets squared, take 5 squared. Okay, so I'm going to rewrite that part as 2z, take away 5, multiplied by 2z plus 5. So I'll factorize this here. Now I've got 4z squared plus 25. Again, I've got that same idea where I've got plus. So I'm going to use the idea, I'll go slow to start off with, use the idea that if I was to take away 5i squared, that's the same as 25. Because I squared gives me negative 1, and then the negative in negative gives us a positive, and 5 squared gives us 25. Okay, now I haven't finished with this. I need to use a difference of 2 squares, as I did in the previous examples. 2z take 5, 2z plus 5, and then difference of 2 squares here is going to be 2z take 5i, and then 2z plus 5i. Okay, and then that is it fully factorized in terms of linear expressions. And notice again, we've got z to the power of 4, so therefore I've factorized it in terms of 4 linear expressions. All right? And if I wanted to, I could work out the roots. I could say 0, the roots occur when this expression here is equal to 0, and then I could use the null factor law for each one of these being equal to 0 to work out the roots. Okay, I hope that helps. Thanks, guys.